Here we go. Today, let's continue on with example. We're going to continue on with area problems, okay? So let's just, before we begin, let's remember, I want you to always do these area problems by adding. Remember, how many people remember the formula? What did I tell you? The formula for the area problem is always saying it's going to be, yes?
A equals L times W.
Oh, that's for area of a rectangle, right? Okay, length times width is the area of a rectangle. But what I'm saying is, when we have these area problems, I told you I want you to be adding these. Yes, Rania? What is?
Total area equals area 1 plus area 2.
Yeah, total area is equal to area 1 plus area 2. I want you to be always adding these. Does that make sense? I want you to be adding these, okay? So, area 1 is, of course, smaller 1 plus the area increase or decrease, right? Depending on the problem, right? Sometimes the area gets increased, sometimes it gets decreased. Who wants to read for us number 2? Go ahead.
An oil painting is 10 inches longer than it is wide and is bordered on all sides by a 3-inch wide frame. If the area of the frame alone is 402 inches squared, what are the dimensions of the painting?
Good.
Question mark.
Right. Now, show me with your finger, is this type 1 or type 2? Remember type 1 was the border all around it. Type 2 was the L shape, right? Okay. Good. This is type 1. What gave it away? Who could tell us? Yes. How about Thomas? Sorry.
It says it's bordered on all sides.
Yeah, it says, where does it say? Yeah. It bordered on all sides. That gives it away. Does that make sense? So if it didn't say that, you wouldn't know. Well, so you think about frames, you know, it's sort of obvious. So I want you to now all declare your variable and draw the figures. Go ahead, I'll wait. Okay. Can you declare the variables? What are the unknowns, by the way? Unknowns are the? How many unknowns are there in this, by the way? 2. What are they? Yeah, the dimensions of the paintings, right? Length and the width of the painting, right? And go ahead and draw the picture with the, of course, border, okay? The frame around it, okay? Go ahead. I'll wait. So, can somebody tell me what you did for declaring the variables? Raise your hand if you got this. One person? Okay, a little more. Eway, what did you put?
Then W equals width and then W plus 10 is length.
Yes. So, of the what, though? These are talking about the width and the length of the? Yeah, the painting, right. So, how many people got this right? Raise your hand. Yeah, any questions so far? Is this okay? Now, what kind of pictures did you draw? Did you get, this is what I got. Let's see if you guys agree. I got this. Okay. Thank you. So there's a painting in the middle, and then we got the width, and then the length, which is W plus 10, right? And isn't it 3 all around the whole thing? So how many people wrote down W plus 16 for the length, the new length? Of course, the length of the whole picture with the frame. Very good. What about the width? What do I write for width? Who's got this one? Arleth, what did you write? I mean, Arla, what did you get? What did you get for the width of the whole painting, Arla? So if this is W right here, and it's W plus 6. How many people wrote down W plus 6? Did anybody write down W plus 3? Okay, do you see why that would be wrong if you did that? Right? Why is it 6? Where am I getting 6 from? Sabrina? Yeah, question first.
With W plus 16, is it okay if we did W plus 10 plus 6?
Which is?
W plus 16.
Which is better?
The W plus 16. I know,
Good.
but would it be correct? Like,
What do you think?
Yeah.
No. That's not simplified. Why would you write W plus 10 plus 6, right? That's not simplified. Yeah. Yeah. So, any question? Did anybody put down W plus 13 here? That'll be wrong, right? You have to add, right? You have to expand 3 and 3 top and bottom and left and right. Does that make sense? Okay, so please do that. All right, then let's write down the equation. Okay, so I told you the equation for these type of questions, whenever there's like area problem, it's going to be total area, the whole thing, right? It's equal to the rectangle plus area 2, which is the area increased. Okay, so anybody need more time to write that equation? Okay, who thinks they know how to do this? Here's the picture. The total area is the picture plus the frame, right? So what do I write here? One person knows? Somebody tell me what to write. 2 Lisa, can you tell me what to write? Uh-huh. Right. W, so the area of the picture itself, you set the total area correctly. So I wrote this as you said, W plus 16, right? Times W plus 6 equals to W times W plus 10 plus 402, right? Very good. Where did I get 402 from, class? Arvin? Yeah, they told us the frame alone is 402, right? Is it meters, centimeters? Centimeters square, isn't that right? Inches square, sorry, inches square. So therefore, that's what we add to the picture. Does that make sense? And that's the total area. Any question there? Do you understand this equation? Okay, do you see how it's always same? Total area is equal to small area plus the area increase or decrease depending on the problem. Yes? Go ahead, solve. Okay, I'll wait. So as we learned before, of course, we're going to multiply the binomial times binomial this way, where you multiply first term, right, with the rest of them, right, and then the second term with the rest, correct? Who could tell me what we get when we multiply those two binomials? What's the result? Dominic.
W squared
Uh-huh.
16W plus 6W plus 96.
That's what I got too, okay? And then on the right side, of course, W times W is W squared plus 10W plus 402, correct? Question? Oh, okay. Yeah, so next, of course, what are we going to do more here?
You simplify 6W and 16W.
Right, so what do you get? You have like term? Uh-huh. So you have 22W, right? You see you have 6Ws and 16W. Okay? And thankfully, again, the W squares, we're hoping that those will cancel out because we don't know how to solve equations with, right, some variable square yet. Okay, we'll learn that later. So what do we do next year, Cole? Right, by? Good. If you subtract both sides by W squared, isn't this nice? They just go away. And now we get something that we're used to. We get an equation with just variable to the first power. What do we do next year? Eric, what should I do next? Yeah, subtract 10 W's from both sides. And of course you get 12W plus 96 equals to 42. Of course, we want to now get rid of the 96, right? Subtract 96 from both sides. How many people got 22 equals to 306 and W equals to 25.5 inches? So raise your hand if you got that. Is it okay to get decimals like this? Yeah, it's okay. I mean, sometimes it comes out to be a decimal. It doesn't always come out to be an integer, right? Question?
You wrote 22 as 12.
Oh. Whoops. Where did I write 22 as?
Yeah, you did. Okay, 12. 22W is supposed to be 12W.
Oh,
When you
right.
subtracted 10.
What did I? And then I got the right answer. Isn't that amazing? That means I didn't do something right. So this should be 12, isn't that right? So 12. What's 306 divided by 12? Is that 20?
Yeah, 25.5.
Was that right? Okay, so I got that wrong. Sorry. And I had I had the answer magically. I see. Okay, so there's even. Now, what's my length then? Thank you, Amy. Yes.
35.5.
How'd you get 35? Who could answer? He's right.
10.
Yes, Stephanie? You add 10 to this. Why?
Because it says that the length is 10 inches long.
Exactly. It says length is 10 inches longer. Thank you for raising your hand. So there's 35.5. The answer. How many people wrote down? They asked for the dimensions, right? So can you just give me the length or just the width? They want for dimensions. They mean the length and the width. So it's 25.5 inches by 35.5 inches. Okay. How many people got this? Raise your hand. Any question? Does this make sense? Okay. Do you see this very similar type of question that we did yesterday? All right. Okay. Let's try example 4 now. Okay. Here we go. Example 4. Who would like to read for us? Example 4. Go ahead, Brandon.
A rectangle is 5 centimeters longer than it is wide. If its length and width are both increased by 3 centimeters, its area is increased by 60 centimeters squared. Find the dimensions of the original rectangle.
Good. Now, is this type 1 or type 2? Type 1 or type 2? Wait, show me with your fingers. 1 or 2. Is this the one that we're increase or decrease all around, or is it just one side only? How about, okay, good. A lot of, I want 100% participation. Some of you. James, what do you think? 2. What do you say 2, James? Yeah, it says the length and the width are both increased, right? Do they say anything about all around the whole thing? No. Does that make sense? Okay. What are the unknowns in this? Again, it's sort of similar. Okay. Yes, Nicole? The length and width of the rectangle, the original rectangle, right? Because they're now increasing or decreasing? Increasing, right? Does that make sense? Go ahead, everybody declare a variable and then draw the picture. And this time, see if you can come up with the equation also. Okay? I'll wait for you. Go ahead, everybody try. All right, how many people got at least this? Let W be the width, then W plus 5 be the length. Okay? Any questions so far? Is this right? Where did I get this from? Rania, Ria, where do I get this from? W equals to width, and then W plus 5 equals to length.
Problem.
Yeah, where? Which part of the problem? Can you read it?
The rectangle is 5 centimeters longer than its width.
Yeah, the very first sentence tells us that the rectangle is 5 centimeters longer than its wide. Now, then the picture. How many people got this picture? How about everybody take a look at this? Here, this is what I got. Isn't this what we get here, guys? You have the rectangle now is being increased, right? So, right?
Yeah.
All right. So then, how many people wrote down W plus 8 for the width? I mean, for the length. I mean, because you had W plus 5 plus 3, right? Very good. How many people got W plus 3? This time you just need to add 3, right, to the length and the width. This time it's pretty straightforward. Turns out type 2 is sort of easier, right? Okay, now, of course, the formula is always same. Total area is equal to area 1 plus area 2, correct? So there's a picture, right? The whole thing is equal to the rectangle plus the L shape. Okay, who could tell me the equation? How about, let me pick somebody at random here. How about, yes?
W plus 8 in parentheses plus times W
Mhm.
plus 3
Mm-hmm.
equals W plus 5 in parentheses times W plus 60.
Very good. How many people got this? Raise your hand. Okay. Just like Indira said, you multiply the length and width of the whole thing, right? It goes to, of course, smaller, right? Area plus the area that was increased. It's always same. I'm telling you. Okay. Is that easy? Okay. How many people need more time to solve then? Okay. Go ahead. Solve and see what we get. Let's see whether we get the same answer. Okay. Kira, can you tell me what to write? So we need to multiply the left side. What do we get?
You multiply the W's and W and 8.
Right. What?
You get
Mhm.
W squared
Good.
plus 8W.
Mhm.
And then you multiply 3 times W.
Good.
times 8.
Right.
So you get 3W plus 24.
Very good. Okay. How many people got this? On the right side, of course, W times W plus 5. You get W squared plus 5W plus 60. Yeah. Very good. All right. Then let's see. How about Daniel? When I simplify the left side, what do I get? Didn't you do this one? Okay, what do I get on the left side? Well, before you do that, what about 8W plus 3W? Yeah, what do you get when you add those together? Right, there you go. Then, of course, you subtract W from both sides. Isn't that nice? The W squares go away, which is sort of what we like, because we don't, like I said, we don't know how to solve those yet. And then we get 11W plus 24 equals to 5W plus 60. Of course, we're going to get rid of 5W or 11W, class? 5W. Okay, then we get 6W plus 24 equals to 60. Subtract 24 from both sides. Right? Question? Okay, then we get 6W equals 36. How many people got W equals to 6? Raise your hand. Very good. Very good. A lot of you. And of course, if W is 6, how do I find the length, Audrey?
You add 5.
Add 5, because they told us, right? It's 5 more than the width. So what is it? 11. How many people got 11 by 6? The answer? Okay. Any question? Here's the answer. Let me circle it. 6 by 11, 11 by 6. Same thing. Any question? We good?
Wait,
All right.
question.
Yes, question.
Okay, do you know how you said it's 6 centimeters
right?
Why'd you say 6 centimeters squared?
I'm sorry?
Would it be 6 centimeters squared? Is it just left at centimeter mark?
6 centimeters squared? Why would you write that? Some unit square is talking about area.
Oh,
They're talking about dimension.
okay.
And why would it be 6 centimeters squared? Right, it's 6 by 11. Yes,
Can you scroll up a
sure. A little more? Is this good? Okay. More? You want me to go up more?
Yeah.
Okay. Here. Actually, I could show you. Okay, okay, go ahead. If you fix, go ahead and fix if you didn't get this, the whole thing correct. Okay, so, like I said, okay, here, take a look at it.
So big, we can read it so clearly.
So, last time, it's been a while, we talked about rate times time, right?
Do we have to copy this down?
No, I just want you to, I didn't mention this part, so I just want you to understand. Okay, remember, for same direction, there are many cases, right? I forgot one case. Because it was so obvious, I forgot, okay? For case 1 was where they go like this, right? Correct? Case 2 was, one of them could be, case 1, case 2 was one of them, and then the other could be like, it leaves later or something, right? Do you guys remember?
Yeah.
So they have the same distance. Case 3 is so obvious, I forgot. Can somebody tell me which case I forgot for same direction? Case 3. I forgot this case. Yeah, anybody? That's not same direction, that's opposite direction. This is so obvious, I forgot this case.
Around.
Huh? That's a round trip. Yeah.
When they both start at the same place, but one stops earlier.
Have we had that before?
No.
I don't think yeah, we haven't had one where one stops earlier. Yeah. This is sort of case 1. They start the same place and they go. Case 3 is where it's not two things, it's just one thing moving. Or like, this is case 3 here. They go this way, or maybe they go on a highway, and then they slow down because of traffic or something. And it's still same, right? Yeah, so I forgot to tell you case 3. This is like sort of the classic case 3, right? Same direction. Does that make sense? So if that happens, right, they tell you either one of them goes faster because there's traffic, or, and then they slow down because of, I said it the other way. You know what I mean? They go faster and then slow down, or they slow down and then go fast, right? Does that make sense? So this is still a case 3, classic case that I forgot. But please, right, remember that, okay? That could happen also, right? Of course, there are many different variations, but I forgot to mention the most obvious one, okay? This is where cars may be traveling through freeway, going really fast, maybe 65 miles an hour, and then it hits traffic, right? And then it slows down, maybe going 35 miles an hour, right? And then, but the distance is now this whole thing, right? This is okay. Any question? Yeah.
Can we please review the problems from yesterday's?
That's what we're gonna do right now. Any question on this? Okay, does that make sense? All right, good.